Hello class, today we're going to be looking at 5-4 applications of percent part 2. In this section we're going to be finding percent error. Errors are what you normally think is mistakes. The formula for finding percent error is percent error equals the absolute value. Remember, these bars mean absolute value. So the absolute value of the actual value, what it should be, minus the measured value, what you actually measure, divided by the actual value again, the whole thing multiplied by 100. Don't forget that last part, by 100. So pause the video, write down the formula. Okay, here's a practice problem. It's a word problem, so it looks pretty difficult, but we can break it down and make it easy. The supervisor at a shoelace factory checks the length of one shoelace out of every 500 made. If the shoelaces are not within 0.5% of the specific length, that means 0.5% or less, they will be rejected. A 36-inch shoelace she just checked was 35 7/8 inches long. Does she reject this shoelace? Okay, think about this. The shoelace is supposed to be 36 inches long. That information is right here. That's what it should be. But when she pulled one off the assembly line, remember she pulls one out of every 500 to check them, she found that it was only 35 7/8 inch long. So somehow, somewhere along the line, the machine that makes these isn't working properly, because it's not working and coming out to be 36 inches long. That's why they have quality control checks in factories. So what they're saying is, this is the number that the company looks for, the percentage, to see if they should keep that shoelace or reject it. The company wants the shoelaces to be within 0.5% of the amount that they want, the 36 inches, or they don't put it in the stores. Okay, so to solve this, let's look at our formula, the actual value. What is it supposed to be? Well, the shoelace is supposed to be 36 inches long. So we have the 36. Okay, then it says subtract the measured value. What did the person actually measure? Well, they measured 35 7/8, which is 35.875. We divide that by the actual value, which we already determined. Then we take the absolute value of that and we multiply the whole thing by 100. Okay, so when we take 36 and we subtract 35.875, we get 0.125. We divide that again by the actual value. We said that was 36. We take the absolute value of that times 100. And what we get is 0.3472. When we multiply, by 100, that becomes a percent. So this is now a percent, 0.3472%. If it is less than or within the 0.5%, then we don't reject the shoelace. We keep it and we sell it in the stores. So 0.34 is within the 0.5%. So we do not reject it. This shoelace will actually go through to the store. Okay, let's try a practice problem. John measures the mass of a 250 gram standard mass with a balance. John measures 249.7 grams. What is the percent error of his balance? There's a few things we need to look at here. First of all, what should the mass be? It should be 250. What does John measure it to be? And again, here's your big clue. He measures it to be 249.7. So we know our two numbers that we start with, and now we just have to find the percent error. So we take our actual value, or what it should be, 250. We subtract out what John measured it to be, 249. 0.7. We divide that by what it should be, or the actual value, which we already know, it's right here, 250. We take the absolute value of that times 100. What we get is 0.3 divided by 250 times 100, which will equal 0.12%. 0.12%. So this is the percent error. That's all they wanted in this one, the percent error. Pause the video, make sure you write down the sample problem, work it out so you know how to do it. Okay, here's our next practice problem. And again, all these can be found in the textbook. The page numbers and the problem numbers are written at the top. Daniel makes 2 measurements and analyzes his results. In part A, it says, a 10-gram mass measures 9.5 grams. What is the percent error? Well, let's identify what we have first. Here is what it should be, or the actual amount. Here is what is measured, 9.5. What is the percent error? So we have the actual minus what's measured divided by the actual, the absolute value of the whole thing, times 100. And when we do that, we get 5%. So the percent error is 5%. That's only one part of the problem. Let's see what they want next. A 500-gram mass measures 499.5. What is the percent error of this one? Pause the video and try this one yourself, and then when you're done, start the video again to see if you got it correct. Okay, what you should have done is take 500, the actual amount, minus the measured amount, 499.5, divide by the actual amount, take the absolute value of that. Remember, absolute value means you'll never have a negative number. Times 100. And the answer you should have come up with is 0.1%. Did you get it right? Okay, the next concept or application of percent is finding a registration fee. To find a registration fee, all you do is take the rate times the total bill or the total value. In one state, the fee to register a medium weight truck is 1.5% of its assessed value. What is the fee to register a truck with an assessed value of $14,500? So the fee is the rate, and we have to move the decimal over. So I'm going to have 0.015 times the value of the truck and when we do that, we get $217.50. And that's how to find a registration fee. Okay, now it's your turn. Practice problems 1 and 2. Number 1 has 2 parts. At a sporting goods factory, a worker checks the weights of baseball bats. A bat is rejected if it is not within 0.6% of its required weight of 26 ounces. The bats are supposed to weigh 26 ounces. One bat that the technician checks weighs 26.25 ounces. So in part A, figure out the percent error. In part B, will this bat be accepted or rejected? Number 2. All states charge a fee for using cell phones. In one state, the fee is 1.14% of the bill. What is the monthly fee for a $39 bill? Okay, come in with these tomorrow and we will check them together. Have a good night.